Hey everybody, this is your lesson on distillation, and this is for Lab 1 at RCBC, the Simple Distillation Lab. So let's get started. So you'll notice here that before we get into some of the nitty-gritty, we're going to need to do some definitions. So let's define all of these things so that we know what the heck is going on. So boiling point, this may be something that that you've heard of. That's a joke. But the boiling point, remember, is the temperature that a liquid becomes a gas. Okay, so that's good. My sloppy handwriting here on my computer screen, but you still get the point. Okay, and so distillation is the process of separating a mixture of liquids by using a boiling point. Okay, delta BP, difference in boiling point. Okay, and now this next term, theoretical plate, is interesting because in a distillation, what you do is you turn a liquid into a vapor, and then that vapor then condenses back into a liquid. So if I draw some of this here, let's see if I can get rid of this here. So you have a round bottom flask, and then the liquid will turn into a vapor, and then it will then move down a condenser. The condenser has water cooling, and then it'll fall into another smaller round bottom. And so when the when the liquid turns into a vapor and back into a liquid, that is one theoretical plate. Now, what you can do is you can add distance here. Let me get out my eraser here. So you can add distance between where the vapor is and where it cools. And that now, what it'll do is become a vapor, and then it'll cool back down and turn into a liquid before it hits the condenser. Okay, and then because it's warm down here, it'll turn back into a vapor and go back up, and then up here it may turn into a liquid. The vapor may turn into a liquid, and then back into a vapor, and then it goes down. Well, each place that vaporization, condensation cycle happens is called a theoretical plate. So a simple distillation is called simple, not necessarily because of its setup, but because it really only has one or two theoretical plates. Okay, and so other distillations can have many more theoretical plates, up to 100 or 150, making the distillation more effective. So a theoretical plate is really the liquid to vapor cycle that happens in a distillation. Okay, the more theoretical plates you have, so the more times you go from a liquid to a vapor, back to a liquid to a vapor, back to a liquid to a vapor, the more of those cycles, the more theoretical plates you have, the better the distillation will be, the more precise you can get it. Now this says liquid versus vapor, but I actually wanted to point out gas versus vapor. A gas is normally found in the gaseous state. Air, carbon dioxide, those are gases. A vapor is something that is found normally as a liquid or a solid and then turns into a gas. So things that readily evaporate, those would be vapors, or things that you boil. So I point this out because I didn't know the difference between a gas and a vapor until I was well into my educational career. So like maybe even a graduate student. It's just something that slipped through the cracks in my knowledge. So I thought that I would let you know. So a gas is something that is normally found in a gas at regular room conditions. A vapor is something that is normally a liquid, could be a solid, but is usually a liquid that turns into a gas because you heat it up. So that's the difference there. Okay, but now there are 3 different kinds of distillation that we're going to do. Okay, and so but a distillation definitely is used to separate liquids, and it uses boiling point, and then there's a whole bunch of specialized equipment used in here. Okay, so I pointed out a couple. You'll see here that there's a round bottom flask right here. Okay, so we abbreviate that RBF. Think of an Erlenmeyer flask, but it actually is round. It's completely round, and that's to provide even surface coverage for heating and reactions. Okay, and then the other thing is going to be this. This is called a condenser. And these things are probably the most expensive part. Water always goes in the bottom and then it comes out the top, okay? And water jackets that central column in there. So your liquid will go up from here and turn into a vapor, and then it'll go down in the middle here, and then it's cooled by that water that's floating around in the condenser, okay? And so it's not intermixed. It looks like it's intermixed, but it's not. And then over here at the very end, you have another round bottom flask. This is a smaller round bottom flask, and this collects your distillate, the thing that is you're trying to purify. Okay, the last thing that I want to point out is this guy. This is called a vacuum adapter. I'm running out of room. Okay, ADAPTER. And the vacuum adapter allows you to hook your distillation apparatus up to a vacuum pump and do your distillation at low pressure. So we're going to go over the 3 different types of distillation. There's many types of distillation, but 3 of the common types of distillation. So we're going to talk about simple distillation, fractional distillation, and vacuum distillation. Okay, so distillations in general work because the liquids have a different boiling point. If the liquids have the same boiling point, then it's not going to work. They have to have different boiling points. Now, in the case of something like crude oil, there's petroleum distillates can have just a difference in boiling point of 1 degree Celsius. Like you can distill things. It's hard, but you still can. Okay, and so what happens is exactly what I explained in the last slide. The mixture is heated up into and the boiling point, the temperature is that of the lower boiling point liquid. That liquid, the lower boiling point liquid, turns into a vapor. It stays there. It's the higher boiling point liquid, or the stuff that boils higher, stays in the round bottom flask. And then the lower boiling stuff turns into a vapor and leaves the mixture. The vapor is cooled in the condenser, and then the temperature, once you have collected all of the lower boiling point stuff, then you can move on to the next lowest boiling point, or if in the case of two components in the mixture, then you move on to the next one, and then you'll be all done. Okay, so you can do this for as many different types of as many different things that are in the solution. Okay, so simple distillation. Simple distillation is called simple distillation because it really is pretty easy. It has 1 theoretical plate. So remember, it undergoes 1 vapor to liquid cycle when the vapor goes up to the condenser and goes through. It could be 2, but that's I don't know. And then you use simple distillation when the temperature is usually 100 degrees or more. When you only have 1 or 2 theoretical plates, the difference in boiling point has to be pretty great in order for it to be effective. Okay, and so you should also use simple distillation when you can easily achieve the boiling point of each substance. Okay, so easily achieve, I will say that the cutoff is somewhere around 300 degrees Celsius. We can easily get to 300 degrees Celsius in the lab. After that, then we have to use other means that are a little more complex and or dangerous in order to get really high temperatures. So typically, if we're going to do simple distillation, we want the boiling points of the components of the mixture to be below or well below 300 degrees Celsius. Okay, and the other thing is that typically we just want 2 components in the mixture. If there are only 2 components, then that makes it easier. Now that's not because all 2 component mixtures can be separated, but it's 2 components because it's more likely that if there's 2 components, the difference in boiling point is 100 degrees, and that the boiling points are easily achieved. Okay, so this is again a typical simple distillation apparatus where the mixture you start off here is going in, it turns into a vapor, and then that vapor takes a right-hand turn here and goes into the condenser and turns back into a liquid, and then will drop out into the receiver. Now, if the vapor happens to go up and then go back down a little bit and then heat up and then turn back, it turns into a liquid and then goes back up. That just means there's a second theoretical plate, and sometimes you can actually see that in the lab when you're doing this. Okay, now fractional distillation is used, and that has a whole bunch of theoretical plates. Okay, so you can have 100. You could have 100 theoretical plates, and if you're talking about something that has 100 theoretical plates, that means that you're doing something that is that much better, has 50 to 100 times more theoretical plates. So that means you're able to separate compounds that are a little more finicky. So you typically use fractional distillation when the boiling point is less than 100 degrees. Some places you'll see 75 degrees, but I like the idea of 100 degrees because it's just a nice round number. And again, you want to make sure that the boiling points of each of the component of the mixture is easily achieved using common heating methods. And sometimes if there's 2 components or more, again, this has to do more with this, because if you have 3 or 4 parts of the mixture, a lot of times that just means that their boiling points have to be shoved in together a lot more close. So that means that you will do fractional distillation if there's more than 2 components a lot of times. Okay, so you do fractional distillation if you have something like crude oil, okay, because crude oil has so many different parts to it that they fractionally distill it, and it actually is pretty a crazy process. So But that's there. So the difference here, this is the standard simple distillation, and so what they do is they add this. This is called a fractionating column. And the fractionating column, all this does is add space and surface area so that when the vapor comes up from here, it then turns back into a liquid, and then it's heated up and then turns back into a vapor and then back into a liquid. So that process, that cycle of going from a liquid to a vapor back to a liquid, you get a whole bunch of theoretical plates, and you get a whole bunch of separation until it comes down through the condenser in here. So they're very similar in terms of apparatus setup. Okay. So, and then vacuum distillation is actually just a supplement to regular distillation, whether it's simple or fractional distillation. What you can do is, if the boiling point of the component of the mixture is high, like above 300 degrees C, instead of finding some sort of alternative heating, what you can do is take advantage of gas laws, right? And you can say, as you decrease the pressure, the boiling point of the liquid is going to go down. Okay, so I guess that's not quite gas laws, but it is when it turns into the vapor. But the idea here is, if you apply a vacuum to either of these setups, here at the vacuum, there should be a little vacuum adapter. Now the boiling points can be well below 300 degrees C, and you can do your distillation very easily. As an aside here, vacuum distillation is used in our organic lab to get rid of ether. Okay, ether is a solvent. It dissolves lots of organic stuff, and ether has a boiling point, a normal boiling point of 35 degrees Celsius. When we apply a vacuum to this, we can actually get ether. We can get ether to boil off at below room temperature. So if we lower the pressure, this may boil off at 15 degrees Celsius. So we boil it at 15 degrees Celsius. That's well below room temperature, and so it boils off without us even applying any heat. So it could be a time saver and an energy saver by using room temperature as the kind of the the source of heat for this ether distillation. So, I mean, that's one way that we use it. Okay, so that is distillation and the three of the common types of distillation, and when to use them, and some of the vocabulary that goes with distillation. So if you have any questions, feel free to reach out, and have a great day, everybody.